Alright, time for another DraftPhysics.com video presentation. So, it's debate physics also, but the debate obviously isn't in any way coherently arranged or ordered because the opposition refuses to actually do anything other than misparaphrase the arguments made and to evade all of the pertinent, relevant arguments. So, so I will play some of this Brozosian nonsense video, and so it's just more details about Clay and the Mythbuster experiment. So, I just did a video on Clay, so if you want to know how Clay works, watch that video instead. And if you want counter arguments to all of this mush, this will just end up with more details. That's pretty much all that's going to happen. So we'll just play the intro and then I will play it and paraphrase it as I go. Accurately paraphrase it, by the way.
Hello, Ian.
Hello, Ian, he says. We need more volume. Surprise, surprise.
I tried to post.
Oh, too much. Too bad everybody can't just play at my volume.
Posted a message to you yesterday. It didn't stick, so.
Blah 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 blah. So anyway, he posted a comment, not a message, okay, on his video, and apparently it's I got some kind of phrase in it that's YouTube doesn't allow, so it didn't post. So instead of just emailing it to him, he gave up, I guess.
I'm just going to read it out because put a bit of thought.
Yeah, whatever. Yes, put a bit of thought into all this gibberish.
Into it, so it's worth at least trying to get the message across.
Not really. Okay, so that's it. There's no point. Well, okay, play a little more.
So I said the good thing about using tried and tested clay instead of plasticine is that it is continuously reusable.
So plasticine is so again, this is sort of a non-argument. It all can be humidified back into its non-dried state. Blah 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 blah. Unless you're using something that really bakes at a low temperature, it's not that big a difference. Blah 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 blah. It's all just a suspension, and you're just saying how thick is the suspension. As I pointed out in previous videos, you can make a suspension that behaves exactly the opposite to clay. That is, that yields not at all to velocity and, is cornstarch. And it will resist anything with a high velocity, and it will permit things with lower velocities to pass. So yes, there's no one arguing that clay has been proven to be perfect. We don't have any of those experiments, but you could just argue theoretically it should come somewhere close to representing the energy that impacts it and such.
No matter how dried out it becomes.
Alright, so this is just some sort of minor argument about the difference between Play-Doh and clay, which isn't enough of a difference for anybody rational to worry about. But anyway, so we'll skip over this crap. So I'll pause. Right. So in this section he first uses the word homogeneous. Okay, so he uses about 14 times. And the idea is that the clay has an even consistency. And whether it needs to be perfect or not can be argued for these kind of tests. We're not making pots, we're not baking this stuff at thousands of degrees. We're really not going to stress it that much. You're just going to squish it. And so the argument is you just need something moderately even in its construction. It can't have like water bubbles in it or some other kind of crap. But really it's still going to take the energy to move this stuff, and that's all you're talking about, is the fact that you're going to move it and how much energy does it take to move it per atom. And the argument is that it's fairly consistent in that every atom has to do pretty much the same thing. It has to go sideways. Okay, so I will play some more and get to something maybe more interesting. Oh, yeah, no chance. Alright, so I will play this little bit, just because he's, you know, he just makes stuff up.
The potter, no matter how skilled, could not turn a pot using plasticine because it has a weird consistency, doesn't it?
So, says he. Okay, so obviously I have used plasticine type object, you know, clay before. I have done some sculpting, and there's no real problem. It moves fairly well. So the fact that it's a little stiffer in some respects, it's still, you dent it, it stays dented. It's just kind of bullshit to make up this fable that somehow you can't mold or use plasticine to represent something because somehow it restores back to its original condition. It really doesn't do much of that. It's not very elastic. Alright, so here, you know, this is such a side subject, but he's making this argument that plasticine behaves fundamentally different, blah, 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 blah. So he wraps the stuff in cellophane and then throws it against the surface and claims one is more elastic. And it's just not a good experiment, so we'll play this part, because it's going to be stupid.
That's my guess, anyway. I thought I'd better put my money where my mouth is, Ian, on this clay versus plasticine issue. No criticism implied, really. It's just, I think it's an honest mistake to think that that it works the same as clay, but that's a bull.
So he's wrapped them, okay, which doesn't allow them to have a place to go. Essentially, it's going to be resistant, and we don't know how evenly wrapped they are in any way. This is just such nonsense.
Ball I made out of plasticine, well, Play-Doh. And that's a ball I made out of medium
really
soft clay.
Look as bally to me.
Similar consistency, and dropped
really
them both on the floor,
on
and
top,
you can see
frankly.
that's recorded the damage.
Yeah.
Flat, and that just bounced. Couldn't even tell.
Yes. Well, anyway. So really, is it much of an experiment? Yes. So one of them, frankly, expanded in the plastic without reshaping the plastic, and one of them didn't. So what? Does that mean that if you compress them, that it's going to go back to its original condition when it's not in plastic? I don't think that's what it demonstrates at all. But anyway, just kind of a bullshit. Yes, very much bullshit, actually. I mean, we know that when you hit it with a weight, it's going to compress, and it's going to stay compressed. It's not really an argument. We've already seen it, actually, so it's not really much of an argument. I suppose we might as well watch the great, whatever you want to call it, experiment.
Clay on the right, plasticine on the left.
So it's rolling away, okay, because yes, the energy went back into the clay and back out of the clay, and it reflected, it bounced. It doesn't mean it doesn't have a flat side, but he's not going to show us that. No
Can't even see a flat on that, really. Whereas that, flat as a pancake, recorded the energy expended. That too.
Okay, so doesn't mean a thing really, because we're not wrapping the clay in plastic. And even if you did, with a weight hitting it and it doesn't have anywhere to bounce to, it's not going to make any difference. It's not going to bounce in these experiments. But anyway. Alright, so now he's talking about experiments he's done before. Now we saw none of these. So let's just understand, he did all these clay experiments and he didn't post any of them. And one could argue that because it doesn't demonstrate what he wants to demonstrate, and that's all this is about, is finding some little niche experiment that comes out his way, and that's the one he'll ride, and the rest of the experiments he'll pretend never took place. And that's all the Chartelet experiment with clay was. That's all her experiments. Every experiment she did, she was a Leibnizian, was trying to prove Leibnizian theory. She didn't bother with anything that didn't come out her way. So she didn't publish that. So it's the same kind of crap science in the sense that it's really not an effort to reveal the truth. It's an effort to propagandize for a claim. Period. And it should be understood that that's all it is. and a higher level of scrutiny should be applied to the evidence. The advocate should be scrutinized. You should know the lawyer's trying to trick you. It's not a, there's no lie. He's being paid to trick you. He's being paid to trick the jury. You have to scrutinize the evidence.
It's gone rock hard now. From about 9 months ago, I suppose. I even did square ones there. You can see that was the height it started out at. That was the height it ended up at B1. Not much.
So we have no confidence that he did any of these experiments legitimately or correctly. Making towers of clay and then measuring the height of the clay, kind of bullshit when you don't know how it's expanding over the whole distance of the clay. So really bogus.
Much different is the, and that's the height it ended up with B2, but you can see it.
So tiny amounts of difference in big giant stalks of clay isn't a good way to measure. It's bad theory as a way of doing the experiment. You want to try to make your measurements, you want to try to make your differences as big as possible, like almost like viewing a double slit pattern on as big a far away wall as possible, because it makes all of the measurements so much easier to do. You want to expand the measurements. You don't want to put the measurements into a smaller and smaller amount of distance. And so obviously he does it that way because it's to his advantage to keep things as fudgy and foggy as possible. You don't want to reveal the truth. They want to propagandize for a story they want to tell.
I couldn't get it to squash exactly, and these were really hard work to make these exactly perfectly straight, so they're exactly the same weights, etc. Compress it all at the, that must be fair, let's show the side.
So you really can't see that. It's his fault. He didn't aim the camera properly.
Where you can see some compression. Just a slight reduction in height, and it looks like more like 4 times more there. Don't it, because I've allowed sufficient clay?
Yeah, it looks like. Now it doesn't really, and you can't see it anyway. But obviously these are tiny, less than millimeter kind of things to be measured, and there's no point in measuring those small distances.
For that to happen. Every picture tells a story, doesn't it? There were loads more, but I've destroyed them because, just use the clay again and again, because like I say, it's all reusable. Oh, just one more thing, just to show you.
It's not reusable in any easy way, so again, it's hardly cheap.
Massive amount of clay you get for 15 quid, that's only part of it. Delivered. The problem with springs...
doesn't sound like a bargain to me, but fine. You spend your money on... he still smokes regular cigarettes, so what does he care about money?
That it all happens so fast that we end up having to video it at high speed or use some other devious method.
Alright, so again, so silly, but he actually did come up with a method of measuring distance where you just put a blob of something on the surface that's going to move, and you just find something that takes 1/1000th of the amount of energy to move, and then it just stays where you did. He actually used a little blob of clay, and the little blob of clay would get deformed in a certain amount of distance, and that would tell you how far something went. So it's not that hard to record an impulse energy. You don't need to use a high-speed camera to know how far did it push the scale. So if I want to record this, I can just put something on here that moves with the plunger but doesn't gain any momentum itself, and it stays. Once you pushed it somewhere, it stays there, and that'll tell me the impulse. So it's his own invention. He's pretending he doesn't have knowledge of it. It's just ridiculous. I mean, it's ridiculous for him to argue that this is somehow difficult. It's not that difficult.
Means of trying to determine, what happened in a microsecond.
Yeah, springs work just fine, but whatever. It's not going to help you any.
So, and it's just not worth the hassle when we have evidence that clay really is a good measure of the energy.
So we don't have any evidence, but whatever. I mean, the theory, the logic says yes, but there really isn't any good evidence. There aren't any experiments testing that. So it's not very useful to say you have knowledge of something when you don't have any knowledge of it at all. And the reason why he says it's good is because of the dropping round things into clay. So I did the video, the clay video explains for the 50th or 75th time that there's no good theory to dropping round things into clay to measure how much energy is absorbed. It doesn't work very well. It's not very linear. Round surfaces aren't linear. Alright, maybe I'll pause here and we'll just see if this is of any use at all. Alright, so here's going to say the magic words.
Indeed. So long as we do it the proper way that Will and Gravesend and Emily de Châtelet, whoever else showed us.
Whoever else, there weren't that many else's. So let's understand Gravesend and de Châtelet were both Leibnizians. She was tutored by a Leibnizian. It was a theory she wished to prove in opposition to almost everyone else on Earth. And the experiment it fools a simpleton, but it's not theoretically sound. The experiment has a defect. It is falsifiable, and I have falsified it. Okay, and he's pretending that hasn't happened when it has. Let's see what else he says.
And even I showed not the massively flawed way that Mythbusters.
So massively flawed. So squishing clay is massively flawed, but dropping round things into clay isn't massively flawed. And I would say the truth is exactly the opposite. The one that's massively flawed is the round idea, arrowhead. Using a shaped object is on its face, even in just a superficial physical way, you can understand shapes matter. And then if you go a little further, you can understand how far the object penetrates with a shape matters. If the shape is changing as you're penetrating the object, obviously that would have an effect. I mean, obviously.
Attempted. It's flawed on a number of counts. One, as someone already pointed out, it cannot possibly give a linear measure of energy expended because the surface area is constantly increasing as it...
So this is just nonsense. It doesn't matter what the surface area is. It's a certain amount of pressure in one direction. It doesn't matter whether you impact 500 atoms or just 5 atoms. It's a certain amount of pressure, and it's going to make the same difference in terms of pushing the clay sideways. All the clay has to go sideways. There's nowhere else it can go. It can't go forward, can't go backward, it has to go sideways. So it doesn't matter the surface area of the impact in the clay, nor does it matter that the clay expands on the outside. It's like saying that somehow the water coming out of a hose gets in the way of more water coming out. No, it doesn't.
Compresses, it gets faster, doesn't it? Therefore, the lengths measured in the two drops are not directly comparable, and it's not even a consistent expansion. It suddenly stops expanding at some point because the clay squeezes out, as I'll mention in point 3 in a second.
So none of this is real physics. None of this is proven science. There's no theory defending this. It's just moving little atoms, and you have to move them down and then sideways. Down, then sideways. Down, then sideways. That's all that's happening. It's like a water compression. It's like a water wave. You're going to get a pretty good reflection on the surface of what happened under the surface. The water's expanding up because the water can't go the direction it wants to go. It's going into pressure. The pressure says you can't go that way, so the water goes up. That's all that's happening. And the clay is going to do the same thing, and the lump on the outside is essentially the same thing as a water wave. And it's going to be relatively proportional to what's happening inside the clay.
Two, in Mythbusters' case, they unintentionally, I suppose, spoiled the experiment by over-compressing it on the first run, V1. So it could not possibly show 4 times compression.
So he's complaining that they didn't put enough clay in the gun for his theory to come true, when clearly it wasn't necessary. I guess they would have found that out if they ran out of clay. But they didn't run out of clay. So his argument is there's not enough, the glass is half full, and he's saying that's not full enough because I need to empty it plus more. Well, the fact is that you didn't come close to emptying it. So I guess this is a good point as any to draw some of this. Alright, so there's a lot about the Mythbusters video to complain about. I complained that they couldn't even get what they were actually trying to prove correct. So they were actually trying to prove that 250 mile an hour crashes, okay, are somehow different or not different from one 100 mile an hour crash. And the simple argument was they theoretically looked at it the wrong way. The guy basically said, well, 250 mile an hour crashes, that would be you standing in the middle, really. Okay. Is, from your perspective, different. Now, from the 50 and the 50 guy, it's the same as hitting a brick wall. They're not going to tell any difference. So these springs here don't feel any difference. They're getting an absolute null, saying you can't go forward. The brick wall and this 50 are the same brick wall. It's the same thing. Because this is essentially just doing it with 2 springs. You're creating an impact with 2 springs instead of just 1 spring in between. So the logic would have been, if they were going to do this experiment and smash things into each other, they should have put the spring in the middle. It's just so obvious, and that would have measured 100 miles an hour. So 250s do equal 100. You just have to have the spring in the middle, and you can't have 2 springs. If you spread it over 2 springs, obviously the 2 springs are going to say only half the impact happened on each one of those. So that's what they were trying to prove. The fact is it's a perfectly valid experiment. So when they crash actual cars into the brick wall, okay, guess what? Twice the velocity does not create 4x the compression of the cars. So the cars do in fact compress pretty linearly, indicating a 2-to-1 relationship. Twice the velocity, twice the mass of a car. And then the clay did essentially the same thing, close to it. Now the fact is that they made a lot of mistakes. We couldn't be absolutely sure that they dropped from the right height. So there was some original argument by Brozo. So he doesn't mention it anywhere in this video that they got their 43 versus 49 degree thing wrong. Okay, and that would have made a difference in the sense that obviously if they dropped it from too high here, alright, so this height wasn't 1 unit of distance, it was more than 1 unit of distance. So they made a mistake similar to Gosling's mistake, except in the reverse, giving the one mass object way too much energy. And guess what? That's exactly what the results indicate actually happened. But regardless, it's just kind of ironic, right? It just shows the duplicity. This was a very big subject to Brozo when I first used this video as an argument. And now it's not an issue at all, when this perfectly explains what actually did happen. So he is correct. When you're measuring the impact on the clay, you have to measure the part that's missing, not the part that remains. So it's the amount of absent space, the space that's not occupying anymore. So if the clay is reduced to this size, this is the thing you have to measure, the part that's missing, okay, not the part that's remaining. And so they did make that fundamental error. And so by distance, okay, they did get the right answer in the sense that it was twice the compression, in the sense that it was twice, half the amount of clay was remaining this way. But by displacement, it's not quite right. So the real numbers, he has numbers but they're wrong, is 1.1, and they should get 2.2, and instead they got 1.8. Alright, so way short of 2. Okay, so it didn't compress twice as much. But of course, if they did drop the one mass from too high, then this number would go down, and you could say then it would be like 0.9, and that would be, you know, perfect. So that could be the cause of the inconsistency with a perfect 2-to-1 relationship. Just understand, their actual results are short of, here's my theory, okay, let's see, we'll just erase this. Alright, so my prediction is here, their prediction is here, okay, and what happened is here. So just understand, it's so much further from their prediction than it is from mine. Okay, it's on the wrong side. Their results are on the wrong side. They're not like here, here, here. No, they're on the opposite direction of his result. So not even close. So the whole issue that, okay, they compressed the clay and they didn't have enough left to compress it 4 times more. So what? It didn't compress it 2 times as much. Why do they need more clay? More clay wouldn't have helped. It wouldn't have changed anything. If they had added more clay, it wouldn't have come up with 4. It's short of 2. It hasn't even gotten to 2. So it's clearly not because there wasn't enough clay left. There was plenty of clay left. The fact is there wasn't enough energy. And that's the truth. And there never will be, realistically. It's not a reasonable experiment. So anyway, so the Gosling character just dropping the simple weight down onto the clay got a perfect result in the sense that he used a half mass from 4 times the distance, so the 2 clays would compress the same, and he got exactly that result with a simple experiment where he just dropped the weight on the clay. So to pretend that the evidence is leaning in their direction is just a lie. The evidence is clearly leaning in the direction of momentum ruling and KE just fooling.
Even if that were possible anyway in an ever-expanding surface, because there was obviously insufficient clay left to compress that amount. So it's fun.
So it's just a lie. I mean, there's plenty of clay left, and the clay doesn't get harder to compress. You could even theoretically argue that it gets easier to compress because the pressure opposing the downward direction is increasing a little bit as the clay starts to run out. So you're running into the pressure quicker, and the escape hatch is closer, moving sideways. So he has no evidence, or he's not going to be able to link to any clay video, okay, that demonstrates what he's saying to be true, that somehow clay is harder to compress. As you compress more of it, somehow it gets harder and harder to compress. So there's no evidence of that. Alright, this is the bit where he goes on about they weren't attempting to measure kinetic energy. Completely irrelevant. Doesn't matter what they were attempting to do. They did an experiment that revealed functions, and all you were interested in, does the experiment reveal the function? So it doesn't matter what your intent is. You could throw a baby off a mountain and you can have lots of intents, but the fact is it's going to be an experiment for which you could glean lots of stuff. Now maybe the guy threw the baby just because he hates babies, he wasn't trying to do a physics experiment, but the fact is it will be a physics experiment. So it's really just so bogus to say they weren't trying to. It doesn't matter what they were trying to do. The experiment speaks for itself in terms of its physics.
He never even mentioned it, not once. All they were trying to do was...
So that's also a lie. They did mention it, okay? And towards the end of one video, I mean, the show was cut into 2 pieces on YouTube, but they clearly did mention it, and then the guy, to justify it, he took a tin can and crushed it between his hands and said, see, tin cans don't crush even. So what? It doesn't explain why you're so far away from the 4 times the energy, or twice the energy. You're not even close to getting the result of kinetic energy being confirmed. You're at 2 to 1. You're supposed to be at 4 to 1. It's a huge miss, and it's a huge miss in the cars and in the clay. I mean, both experiments don't show anything close to the 4 to 1 relationship. So it's just more lying. I mean, just lied to say they didn't mention it. They mentioned it and washed it away and just kind of said, well, blah, blah, cans don't crush even. Not much of an explanation. Clay isn't a tin can.
Make a model of a car crashing at 2 different speeds, mainly for entertainment purposes.
So again, it doesn't matter what their purpose was. It's a physics experiment. They did crash the car at high speeds into a wall, and the fact is, if you look at the crushed cars by displacement or by how much car is left, it's pretty close to a 2 to 1 relationship, not a 4 to 1 relationship. So the 100-mile-an-hour crash doesn't have any real appearance of being anywhere close to twice, 4 times the energy. Just twice, that's all, not 4 times. Nowhere even close. So this is, again, is just more of his rewriting the actual history of the video. Alright, so here he's making a whine about the fact that there wasn't enough clay in the cylinder to do 4 to 1, because the first V1 compressed it halfway. Obviously, compressing it 4 times as much would be, he'd run out of clay. Doesn't matter, they got nowhere close to it. So again, it's irrelevant. There was no, these two cylinders didn't come close to meeting each other. So there was no issue of it ran out of clay. It didn't run out of clay. So it's just a moot point in the sense that the energy didn't show up to push the clay that was there. Why would you need more clay if it didn't push the clay that's already there out of the way? So you really don't need more clay if there's not any energy to push it out of the way. I mean, kind of obvious. Play a little bit of this.
This is before any compression at all, and this is after just V1 compression.
So this is where he repeats things over and over. So he repeated exactly what he just said, for like as if the audience is, like he's propagandizing to a bunch of, 6-year-olds. He's really not talking to people who have any knowledge of physics. He's talking to people he can fool. Obviously. Alright, so we'll play this part where he makes another one of his accusations that are, it's just distortion of the truth, and he doesn't play the clip, he just, quote, minds the video.
This is the lowest energy, and it's already compressed about half. Well, before any compression, he measured the clay at 2.
Alright, so the fact is that didn't happen in the video we saw. So when they did the first V1 experiment, he didn't show how big the hunk of clay was that he used in that experiment. So that's the bogus part. And you would assume that the plug sizes he would use for any two related experiments would have been the same plug sizes. So when he does measure it for the V2, he does measure it at 2.6. Okay.
713. Or in another instance, he measures it at 2.6.
Uncompressed light.
Right, see, this is the clip he shows. Now, he doesn't show us the other clip because it's not continuous with any of these experiments. It's not in the video in this place.
2.6.
So there's no consistency.
Okay, so look, you can argue that they didn't use the same size piece of clay for the two experiments. I would argue that, yeah, they did. Okay, but anyway, continuing. Or not. Let's see what he says. Alright, this will speak for itself.
But even that doesn't mean very much, because the clay is clearly getting faster and faster the more it's being compressed, so it gets harder to be compressed. It's not a linear function, is it?
So he's making the statement that it's not a linear function. He says it's homogeneous, yet it's not a linear function. So it's even, but it's not even. And again, the theory has to be that the pushing outward pressure is somehow increasing because you have little blobs of clay in the way. pushing clay horizontally isn't much work. So there's very little to this argument that somehow the clay has to work harder and harder to push the clay out. It's again like saying the water hose can't push water out because there's water in the way. It really isn't in the way. Okay. If there is an effect, it's not going to be a very large effect. Alright. So we'll pause and see if he says anything. Alright, so this is the part where he's talking about the fact that they should be measuring how much clay is missing, the displacement he calls it. And yes, they should. I agree. But how much does it make a difference? Well, in this case, obviously, it's the difference between it being them implying that it was exactly twice the compression when in fact it's 1.1 to 1.8, so it's not a 2-to-1 relationship clearly. So yeah, it matters. They did it wrong, and now there's every reason to believe they probably got the angle wrong. So he made an argument originally where he overtly emphasized this, very important, these angles, this degrees distance, the height of the clay. Now he's not arguing that because he found that their measurement was way below 2-to-1. You know, it was less than, it was like 2 to 1.7. So it's way short. Yeah. And that means it's even further from kinetic energy. And so now he's not going to make that argument because frankly that argument would fix it, frankly. If they did get it, if they did drop the V1 from too high a height, clearly that would explain why it's not 2-to-1.
Emily du Châtelet, Willem Gravesend, their method. Not
okay, so their method, it wasn't their method, frankly, it was just his method. And again, I have falsified it 50 or 60 times in videos now, and you have ignored every one of those arguments and are pretending that round objects are homogeneous, that round objects evenly apply pressure, that the flat bottom and the slick sides don't mean anything, when of course those angles mean something and you're just pretending they don't. I mean, it's ridiculous to say, I've said it 70 times maybe, and you haven't heard of the argument that round things don't evenly press on a surface? You haven't heard that yet? So this is where he's just a liar, frankly. Just pretending he has no knowledge that his theory, the Granfeld theory, has been debunked. Yes, it has been. And he's pretending it hasn't been. But again, it wasn't her idea.
Gary Guessworks method, counting everything backwards if he doesn't like the results forwards.
Completely unsourced reference.
So it's compressed 1.8.
1.5.
Now that was yet another one of his V1 measurements, 1.5, and this
another one of, I didn't see all those different measurements, frankly. I saw one pretty much highlighted experiment in the video. So whatever, play your game, fine, blah blah blah. These aren't big differences, so it doesn't really matter. 1.6 to 1.7, okay, whatever. They're not going to in any way account for the fact that it's much closer. It's much closer because it's on the wrong side. It's not in between our two. The result isn't somewhere in between our two predictions. It's on the wrong side of your prediction.
is in measuring.
Sorry, I mean, it's just so funny that he's making these little minutia arguments when he's way short of 4-to-1. Alright, I'll pause. Alright, so this is where he's going to talk about his... Now, it's true about the displacement. They measured the wrong thing. They measured how much clay was left, and they should have been measuring how much clay is missing. Alright, clear. I think everybody would agree with that now. Doesn't matter. Doesn't fix this. So here he's going to talk about this being the right thing to do. So he's always talking about homogeneous and how the clay needs to be even and clay needs to be the same stuff and blah blah blah, and he's not paying any attention to the surface he's penetrating the clay with, and he's pretending arrowhead, no arrowhead, same result. He's pretending that this round object isn't essentially a changing shape. It's going from flat at the bottom to sloped on the sides. It's a constantly changing shape, and how deep you go will decide how much of that changing shape you're affected by, whether you're affected more by flatness or whether you're affected more by the pushing sideways. It's a clear argument, it's real physics, and he's ignoring it.
Otherwise, it's like when I drop lead balls into clay. It's like measuring.
So you can see clearly he doesn't drop them into the clay. He drops them onto clay and barely dimples them, meaning neither of them achieve much depth. But clearly the one that goes deeper is going to be pushing more clay just sideways rather than pushing clay down and then sideways. Clear difference.
It's like measuring that distance, the remaining clay, instead of the amount of displacement. It's like measuring the amount of clay.
So he repeats things. He just does this all the time. It's just too silly. Who are you talking to? You really think you're not gonna see? He's so dumb. He doesn't know what it's like to be smart. And when you're smart, the last thing you want somebody to do is repeat something. I heard you the first time, fuckhead. I don't need to hear it 4 times. I don't need to. It's painful to listen to the same shit over and over, asshole. Yeah. Maybe he writes songs like that where he just goes, me ugly, me ugly, me ugly, 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 me ugly, me ugly, and those are the only lyrics, you know, me ugly. I don't know. I mean, I don't know why he likes to repeat everything he says, but I guess he just likes to listen to himself ramble and rant. So anyway, we'll pause. It goes on and on, you know, with this displacement thing, so I'll just show a little bit of it. Now, nobody really recognized that immediately. It took a while for us to figure out, oh, yeah, that is wrong. So nobody chimed in immediately. They should be doing displacement. Yeah, it took a while for us to, all of us, to be informed at whatever rate we were informed. But yes, it was an error we didn't discover until you have to pick at it a little bit and you discover the errors.
That's why we measure displacement.
No, we measure. So he means him and de Charolais and Grant Savanetta, whatever his name is. And so he's just really saying, us Leibnizians, okay, we find one experiment out of a whole bunch of experiments, and we find the one that proves us right, and we ignore the 99 that prove us wrong.
When we drop lead balls into clay, that doesn't tell you the story. That's the thing that tells the story.
So I just keep saying it over and over.
Displacement. The volume displacement is what tells the story, not what's left under.
So again, the volume displacement, if he would have used a round cylinder instead of a flat cylinder, then this experiment won't come out his way, and he knows it. It's only coming out his way because he's using something round. So if he just changes the shape of the object, he drops into the clay, he gets completely different results. And he's ignoring that's the physical fact. So it's just showing how dishonest his presentation of this material is. Alright, just play this one more time. I mean, you know, his argument that somehow clay isn't a linear function. How you compress clay, that it's pretty much like squishing water, and it's all going to be even. Squishing this much water is going to be just as much work as squishing that much water. If I put water in a test tube and I squish it, a syringe, and I squish it out through some tube, it doesn't get harder and harder to squish as I get less and less water. It's the same amount of pressure because you have an outlet that's a consistent outlet, and the outlet here is going sideways. It can go sideways pretty much just as easily, no matter how much clay is left. Would be the simple counter argument to his non-referenced theory.
kinetic energy formula. It should be 4 times V1, shouldn't it?
Yeah, not even close. He's on the wrong side of being anywhere close. Way the fuck off.
Well, if it was a linear function, which it clearly fucking isn't.
So he says it clearly isn't, and he doesn't going to show us any evidence he has that it isn't. That it's harder to push the water out the syringe, depending on how much water is in the syringe. It really isn't.
The clay's getting fatter, and then at some point it squeezes out of the compression zone, so then it doesn't really count in quite the same way. I'm sure it does count to some extent.
It's all going just sideways, and sideways is very low pressure is the point. Whether it gets a little tiny bit increase in pressure, sure, maybe, but it can't be theoretically much, and certainly not enough to say the clay isn't basically linear. But anyway, let him rant. Alright, so he's ranting on this the fact that the clay plugs weren't exactly the same size in all the experiments. But what was clear was they did generally have the appearance of twice as thick as the other clay. So their 2-to-1 impression is maintained. Now clearly the displacement is what he should have been noting. So again, those are wrong results. And again, the experiment demonstrated not some kind of ambiguous answer in between the two theories. The experiment is way short. If you're going to say it's short, it's substantially short of even meeting the momentum theory, let alone any. It's short of 2-to-1. It's way short of 4-to-1. So it's just more nonsense for him to argue that that isn't in itself a rather substantial piece of evidence. That even if you're going to say the clay isn't linear, that it didn't even come close to your theory.
They're meant to be, in fairness. It's only meant as a piece of entertainment.
So the show isn't meant as a piece of entertainment. Its physicists do consult on the show. Let's not play a game that they don't ever think about any of these subjects and analyze them and, review the textbook and all that kind of crap. So yes, it's junk because it's a TV show and they fuck it up. But the fact is that it's not much difference than real science. So if you're going to pretend that real scientists aren't any more fallible than these nuts, the truth is they are, and you're a demonstration of the fact that it's a human problem. Humans are biased, and you obviously have a huge, gigantic bias. Like an asshole. Big bias, big asshole.
Chewing gum for the eyes. Well, some morons think that you can interpret this as defeating all the world's greatest scientists.
So he says it's defeating all the world's greatest scientists when it's exactly the opposite. All the world's greatest scientists didn't believe this. And what you did was propagandize a theory, 200 years ago. That's nonsense, 300 years ago. And that's all. I mean, there's no good science here. You don't have all this volume of evidence. You can't show anything consuming 4 times the fuel to go twice as fast. You don't have any evidence. And it's just, this is it. You got dropping round things in clay and rolling something on a surface. And these are 2 things that I've already falsified as having anything to do with measuring the actual energy the object contains. So it's just amazing that you can sit there and say this is attacking all the greatest minds when obviously they weren't that great. The minds weren't working very well if they couldn't see the obvious flaw in believing in something for which they had no physical evidence. And such. So now he's ranting at some somebody else screen name, and he's ranting about how there wasn't enough clay, so the clay couldn't be compressed 4 times as much because there wasn't enough clay left. As if it would have compressed any more. It compressed its maximum amount of what clay was there. There's clearly clay left. It would have compressed it if it had energy to do it. It didn't do it. So clearly it just couldn't matter that there wasn't enough clay to prove your theory, because it's so far away from your theory. That's the whole point. the energy is so much less than you're claiming, and the clay is revealing that, and you don't even need the extra clay because you're so short. It's so far away from your prediction that the extra clay is completely superfluous. And he's just defending some notion that the only reason why it didn't show the 4 times as much compression is there wasn't enough clay left. There was plenty of clay, and it didn't move it.
A load of numbers that weren't even in the thing until you just admitted that you didn't know where the numbers had come from. I know where they'd come from. You'd pluck them out of thin air to defend Gary. And I have no idea why Mindless Marbles defended you doing that.
So he's just having a little rant about some sort of mistake he made. So he doesn't understand, angular rotation. So when somebody points out to him that you have to account for the fact that there's energy to move something, to rotate something, requires energy. And if something isn't providing it, just like gravity provides the energy to keep the moon in orbit, for example, the moon doesn't have to use its velocity to turn. Gravity does the turning for it. So, but when something else has to be rotated and you have to use the energy of its own velocity, well, then you have to understand that it's going to change how fast it can go. Turning requires you to use some energy. But he doesn't understand any of this.
No idea why Mindless Marbles defended you. Just plucking numbers out of thin air that meant nothing.
Alright, so I don't know what he's talking about, but who cares? Yeah. Alright, so this is more like a little style complaint regarding Brozo. So he lies about something, and then for the 4th time, he's going to play the same clip for a 4th time. And you're just like, what are you doing? I saw the clip. I heard you say that 1.4 thing. It doesn't have anything to do with clay compression, by the way. There's no reason for this 1.4 thing to happen. The 4 times the energy should show up.
That conversation. Well, I think you're a cunt. Cowardly cunt. Just wasting people's time with a...
Yeah, so that's, I think, can be an accusation that is appropriately pointed right at yourself.
Relevant information that you've made up.
Yeah, so you just made up a whole bunch of crap about how clay doesn't compress linearly, how, you know it because it comes out your way. And that's it. You don't have any science to back that up. And you apparently think that round things are more linear than square things. That a flat surface is less linear than a curved surface. I mean, it's that obvious, right? I mean, if I wanted to say something wasn't linear, what do I say? Look at a circle, it's not linear. What do I want to say when something's linear? I want to say, well, look for a straight line. Well, what's the square got on the bottom? A straight line. So it's that obvious. He's using the word linear, and he doesn't even understand that. Obviously, I'm not dropping a linear object into the clay.
How you can defend that, I will never know.
I will never know how he keeps arguing for nonsense and rubbish that's been already logically exposed to be wrong and incorrect.
The kinetic energy formula predicts 4 times that V1 displacement, so that's 5.68 inches. We don't even have half that. The real problem isn't the size of the clay pug.
So again, what's the difference? It didn't make it to 2 inches, okay? So it didn't make it to what you needed it to compress. So it doesn't matter that there wasn't 5 inches of clay because you weren't going to compress it anyway. And that's the obvious truth. Alright, so this is another funny part. He's arguing that they should have used less weight and less distance and just barely touched the clay. And it's such a stupid argument. I mean, obviously you want to create as easy to read a number. I mean, measuring tiny distances, very difficult. Measuring very big distances, changes, differences, very easy. Very easy to do it with a higher precision. So you want to magnify the effect as much as possible so you can be sure of your measurements. And he's saying exactly the opposite, which is really stupid.
So they only compressed the clay a little bit. Then they would have had plenty of headroom to make a proper kinetic energy measurement. Well, if it was a linear function, that is, but it's not, is it? So that is.
So he keeps saying that over and over again. And all the parts you've missed, he just keeps saying the same things over and over again. But clearly it would make no sense to dent the clay less or put less pressure on the clay, because the more dramatic, the more distance you can do anything over, the easier it is to measure the differences.
It's strictly true. You can't expect it to compress 4 times more when it's getting harder and harder and harder to compress it.
So he keeps saying it's getting harder and harder to compress it. So again, he's arguing that it's harder and harder to push fluid out of a syringe. No, it isn't. No, I just throw this in. No, again, there's no logic to anything he says. He hasn't demonstrated any of it, proved any of it.
It's a mess, isn't it? He didn't put enough clay in. They had to put a lot more clay in to...
So again, you don't need more clay if you didn't compress the clay that was already there. Why would you need more clay if you're not going to be able to push any more out?
allow the proper 4 times kinetic energy prediction to manifest.
So he's saying that somehow, right, I got a syringe and you're predicting I'm going to push out 4 cc's and I only have 2 cc's in the syringe, but the energy only pushes out 1.8. How the hell would more water have helped you? Wouldn't have helped at all. You failed to produce enough energy to even push the 2.
I'm not saying that they rigged the experiment, but if they wanted to rig the experiment, this is what they could have.
Well, we know they're idiots, okay? So we know the whole premise was stupid, where they were saying 2 50-mile-an-hour crashes head-on don't create a 100-mile-an-hour impact. Well, of course they do.
Done to convince feeble minds who don't understand the kinetic energy formula.
So, I mean, again, what is there to understand? It's free energy, mushy, vaporous, made-up energy. There's no way to understand it because it doesn't have any consistency. It doesn't make any sense. It's free energy. It's just some sort of nonsense. Somehow I make an object. The argument is, look, they're saying it's really obvious that one person going 100 miles an hour is 100 times more energy than 100 people going 1 mile an hour. So they're saying that if I actually had these things to buy at the store as a pushing force, that they're saying it's so obvious that the one person going 100 miles an hour is 100 times. You get 100 times value for your money. And the 100 people moving 1 mile an hour can't push anything over, can't do any work, it's totally feeble. I mean, that's how obvious the argument is. He's saying I should obviously think, like him, that somehow the one person going 100 miles an hour is going to move more stuff in the world than the 100 people moving 1 mile an hour. When it's just not true. There's no reason for me to think one of them is 100 times more powerful. But that's their theory. And they're saying it's so obvious to them. I'm saying it's completely unobvious to me. I can't see how you can possibly believe that mush.
For like Gary and his fans, morons, the simplest solution would have been to make the hammers less heavy, less dramatic.
So it wouldn't have been a solution. It would have mean your measurements have to be more and more precise. So it's exactly not what you want to do to the experiment. You want to expand the impact. You want to expand the dimensions of what you're measuring, so your measurements become much easier. I've already said that now 3 times. So he plays some more clips over and over, the same clip. Just horrible. So this is where he's going to show his experiment. This is all we're going to get, is these little tiny clips. So this is kind of funny, actually.
In what it looked like and sounded like, that it made a big impression on people than doing a smaller, accurate experiment.
Okay, whatever that was. So that was the smaller, accurate experiment, where we don't get to see anything here. I don't even know what this bar is. I don't know, how much weight is that? Well, I guess it can't change much. It's the same bar for both experiments, but I have to think about that. I mean, it's going up and down, which is not great either. So he should just drop the fucking weights. I mean, I don't know why he's doing this. But that's all you get.
So there's the...
So that proves something. This is much better. Much smaller distances, easier to measure. No, smaller distances, harder to measure.
clay compression when the bottom.
Why didn't you use a lighter weight from a higher distance? If you're, if you're conceding that lighter is better, why didn't you do that?
Some of that was dropped from the 1 foot mark, 12 inches mark. You could do with seeing that experiment in full, really. That will be quite a long video because
you can't see that video, so whatever he's saying is just absolute nonsense. He's never shown whatever that experiment was. But anyway, just rubbish, obviously. Obviously not an improvement over the Mythbuster experiment. Clearly not an improvement. Alright, so here's basically his confession that he only shows experiments that come out the way he expects them to, and that's it.
It's experiment in the world, it's just a rough guide, so I did about a dozen other experiments. I can show you the results of some of those. I destroyed a lot because...
At
the time I was convinced I should be getting 4 times compression, but of course you're not going to get 4 times compression exactly because it's getting harder and harder to compress it the further it goes down, isn't it?
So now that's his new excuse. It's a completely unscientific excuse. Doesn't really get harder and harder to compress, so it's not theoretically meaningful. So it's not enough of it. You could say air resistance. You can say lots of things, but it's not going to be enough of an effect to not show the difference between 2 to 1 and 4 to 1. You're looking for a very huge difference, and he's picking on stuff that can't produce that huge difference. But yeah, there's the admission. So he did a bunch of experiments. They didn't come out the way he wanted them to, so we never saw them. That's the game he's playing. Alright, we'll play a little bit of this slop.
But I got pretty close, 3.5 times.
So he's claiming he got pretty close. So he got way over twice the compression or something. Yeah, I'm sure you did.
Most of them were. But the problem is it would always land awkwardly, and that was the problem I was trying to get over with, similar to what you have managed to get over with quite admirably, Ian.
Yeah, well, really, it's not that complicated. You do the experiment just dropping the weight. You can see whether the weight lands flat or not. So what's the difference? You don't count the ones where it's crooked, and you just count the ones where it's flat. Not that complicated.
By using those bobbins to keep it straight. I don't know why I didn't think of that, because I'm thick, that's why.
Yeah, use friction. Add friction to the experiment. That'll help a lot.
But this one kept it straight, and so this achieved about 4 times compression.
So he's saying he had a successful experiment. Got 4 times the compression. Now, there's no way we're going to see any of that. We're just going to see some weird little clip, and who the fuck knows what he's talking about.
But I don't think it's super accurate because, it was so difficult to hold it at the 3-inch mark and hold.
Oh, yeah, and he's not using a quick release, by the way. So at least the Mythbusters did that. And he just can't accept that he has some obligation to do that.
Hold it at the 12-inch mark. It's so bloody heavy and cumbersome. Plus, I was trying to hold something else to make sure to guide it, make sure it hit the target.
So he's hitting, he's holding, he's guiding, he's doing a whole bunch of fucking variable fudging.
I was holding a piece of metal. I'll show you the full video, and it'll bore you silly, but the results did come out at 4.
You can't see anything, and he's just saying, okay, and they came out 4 to 1. So this is like Gosling not showing the video where it was exactly 2 to 1. I mean, this is just fucking bullshit.
4 to 1. But I don't think it should have done, really. That's why I don't think it's a super accurate experiment. Perhaps I didn't have the clay as homogenized as it should have been, because it did sort of distort a little bit. So
so he says it's homogeneous, but it's not homogeneous. I mean, it's just la 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 la. You can't see anything anyway. It doesn't matter. The experiment's completely uncritiquable because you can't see anything.
I'm not relying on this as full evidence, which is why.
Well, you just said it though. So you said it, but you're not relying on it. Oh, but I said it.
Not published it before, but it was certainly. Then again, Mythbusters' experiment did similarly, didn't it? Theirs bulged out in awkward shapes as well, didn't it?
Who cares? Right, exactly. Doesn't make any difference.
So, If it's fair for them, it should be fair for me, really, shouldn't it? But I don't think it's fair for either of us to use those as good examples. The simple solution is to just go back to the drawing board, go back to Emily du Châtelet, Willem Gravesend.
Okay, so he keeps saying it right now. Again, I've said it in at least 70 or 80 videos. I've pointed out how dropping around objects has no theoretical credibility. And he hasn't responded to that counter-argument at all, as if it's been made. He hasn't countered it in any way. He hasn't drawn a round object going into a substance and pointed out how it's affecting the substance exactly the same. So the flat surface hitting is exactly the same as the vertical surfaces pushing the clay. Pushing vertically and pushing horizontally are exactly the same thing. Now, he hasn't shown any of that.
Experiment, dropping lead balls into clay, measuring the displacement, it comes out super accurate considering it's only bloody.
So again, it comes out super accurate. Vague notion that somewhere this experiment was done, and bullshit. I mean, in the sense of bullshit that you have ever shown that round objects are the same as, it doesn't matter what shape object I put into the clay. So he's already done the experiment without using round objects and it didn't work. And that's the truth. So he already knows the shape matters. And theoretically you can know, well, the shape difference is fucking the experiment. If you want to do it right, the homogeneous, the linear surface is a flat surface. The unlinear surface is the round surface. So he talks about it not being linear. And he's just obviously saying everybody should push a non-linear surface into the clay, and that'll produce a linear outcome. That's how stupid he is. He's actually saying that to you.
Clay, yeah. Keep it simple. So there's the clay compression.
What the fuck?
When the bottom of that was dropped from the 1 foot mark, 12 inches mark. And that, my friends, is fair enough because it's only an entertainment program. It's not an academic science program.
That's fair enough. What is he talking about, right? I didn't cut this at all. So he shows his experiment and then he talks about an entertainment program. What the fuck? I don't know. So was there anything there that proved 4 times the compression? I didn't see anything. So, yeah. Good luck.
Only feeble-minded idiots think it is.
It's a little bit less than twice as compressed as the speed 1x hit.
That makes sense, doesn't it?
It does.
It certainly does make sense that twice the velocity, twice the compression. So again, and this is after they already knew what the car crashes did. They already knew the cars crush at these rates. So there's nothing new here. The only thing they were doing different in this experiment were crashing the cars into each other. That's it. It's the only difference.
Almost double the compression. Total.
These 2 pieces of clay tell the tale.
Hold on a minute. What about all those other pieces of clay that are...
Yeah, I didn't see any real problem with the other pieces either. Lots of very squished ones, lots of not so squished ones, lots of 2-to-1, and no evidence of any 4-to-1s. So, I might as well just play this through.
Completely different thicknesses than you were showing here. You've just picked the 2 that are twice the thickness of one another. But that isn't the compression.
So again, there was every evidence that there was some consistency. Okay, I mean, yes, the big clays were all a little bit, but they were all dramatically different than the smaller clays. So again, he's pretending that it was somehow that they only selected ones that were aberrant. Now they selected ones that were quite average.
Anyway, that's the amount of clay that was left after the compression. This is before any compression at all, and this is after just V1.
Alright, I won't play it again, because it's just the same fucking argument. I mean, please, what a waste of time. Alright, so here he's just talking again, it's just an entertainment program. Doesn't matter what it is. There's an experiment in the video. You can analyze it. It has some value. Just silly to keep arguing it's just an entertainment program. Professor Lewin was an entertainer in a lot of ways. So what? The point is are the experiments valid or invalid?
Just to keep us all happy and entertained. Great job in that respect, yeah. But don't treat it as, but please folks, stop treating it as if it was academic science. It's not. It's so undisciplined, it's ridiculous.
So, and you see his experiments. So he's saying their experiments aren't academic enough and his are. I mean, it's hilarious. It's so fucking ludicrously stupid. His scotch taped together, you know, crapola is somehow an academic or a clinical correct experiment. I mean, hilarious.
It's madness to treat this as an academic.
Right. So why would you treat you as an academic? I mean, it's just so, it's so fucking stupid. So let's see what he's saying here. Oh, he's reading his crap. He's just reading the crap again. Okay. And so it's the same arguments. We'll just show it's the same argument.
Even if that were possible anyway in an ever-expanding surface, with an ever-expanding surface, because...
So it's an ever-expanding surface when you're just really pushing clay sideways. That's it. Sideways is really easy. But you have to go down first. That's the tricky part. And that's what all the pieces of clay have to do. They have to go down first and then go sideways.
There was obviously insufficient clay left to compress that.
Alright, so it's the same stupid, pointless mush. I mean, frankly, it doesn't matter. You didn't come close. You don't need the extra clay because you weren't pushing it anyway. It's too stupid. Let's see what this is.
If they were attempting to measure kinetic energy using the same materials, in other words, clay displacement, I'm certain that they would have simply recreated the classic experiment invented all those years ago, measuring the volume displaced by a ball hitting the clay.
Yes, a round non-linear surface hitting the clay. So you get a linear result by using a non-linear surface hitting the clay. That's his theory. Obviously as dumb as Leibniz's gravity is a per foot force. Gravity's not a per foot force, it's a per time force. 9.8 meters per second. So again, they won't argue any of those points I just made. Alright, so we'll finish it up. Yeah, we're still recording.
At two different speeds. Anyone who wants to dispute the reliability of that needs to explain why we get the same results whether we drop a 4 mass from height 1 or 1 mass from 4 times the height.
Because it's the same reasoning I already gave you. It's a non-linear surface you're dropping into the clay. So the thing that goes less distance is pushing down more, and the stuff that goes further distance is pushing sideways more. One is easier to do than the other. One has to do more work. The initial work is high when you're hitting the flat surface. The deeper you go, the more you're pushing sideways and you're doing less work to get the clay out of the way. Facts. And you're an idiot. And I've already made this argument 100 fucking times.
That needs to be explained, why that is supposedly not a legitimate test.
I mean, it's an amazing statement. It's been explained 100 times.
The proof as good as that clay is a good measure of energy. Don't care what anybody says.
Round surfaces are very linear. That's what he's saying to you right now. Round surfaces are very linear. Can't you see how the curve is perfectly straight? That's what he's saying. That's how stupid he is.
Well, until they give me some evidence as to...
I've already given you the evidence, the argument, that there's theoretical reason to doubt that round things have a linear surface. Yeah, that they're straight. Round things are straight lines. No, they're not. Curved lines are straight lines. No, they're not.
Right, that's wrong. Anyway, thank you for listening to me, and sorry if I have to do it this way, but YouTube does suck sometimes. I would press comment, but I've already done that and it won't post again, just wasting my time. How do we end the video? Oh, that button there.
Yeah, so you can't email. Yeah. Alright, anyway. Just too stupid. Okay. So, he obviously edited the video, so I don't even understand why he's pretending he couldn't have edited it better than he edited it. You know, so it doesn't really show his experiment. Certainly doesn't show 4 times the compression. It's just such a fraud. I'll imply that it came out my way. I won't actually show it. So again, it's just like Gosling hiding from you the experiment that came out exactly as I predicted. He won't show that experiment because you wouldn't be able to find anything wrong with it, and it would speak for itself. All right, so enough of a video. Till the next time and such. Ugh, that was just so tedious.